So today we're looking at chapter 12, day 3. We're going to focus on the parabola. And as you look at it, you can see the parabola sitting over there to the right-hand side. And that's just the basic picture that we have that we know and we've become accustomed to. But you can see that there's some extra information in there that we haven't looked at before that we're going to focus on in this idea of conic sections. The first thing is let's take a look at the equation. Now, one thing you're going to notice differently right away is that you could have a vertical parabola. Well, that's not different. But we're also going to look at what happens sometimes you're going to get a horizontal parabola. Okay? And a horizontal parabola, well, obviously, between the two things, you're going to notice right away is the difference of the equation. If it's a vertical parabola, and this is the standard form or the conic form that you're going to have to make sure you memorize, quantity x minus h squared equals 4p quantity y minus k. If it's horizontal, meaning if it opens left or right away the difference is the y minus k squared group is what's going to be, or y minus k is the group that's squared, and that's going to be equal to 4p x minus h. Okay, so right away you should notice the difference. If the x quantity is squared, it's going to be a vertical parabola opening up and down. If it's a y quantity squared, it's going to be the horizontal parabola opening left and right. Now, the vertex in either equation, it's going to be the coordinates h comma k, just like it was for a circle. But look carefully, in the horizontal, the k is listed first because that's always going to be with the y group. So make sure you notice that as you're going through when you write your equations and figure out your information. Okay, that'd be the tricky part. Please don't get tricked. The focus. Now, the focus is this point right here that we use to draw out our whole parabola. That actually has a big importance with that. And that focus actually has a lot of applications too for some of you guys that go into engineering and other fields like that. You will look at that focus and where the location is to maximize output of different lights and sound, and I'll leave that for you, down the road. Okay. So, but this focus that we need to look at, this is actually P units away from the vertex. That's where that P comes in, as you see in the equations at the top there. So that's going to be P units away from the vertex. And so what we can say is if you have a vertical parabola, what it'll be is it'll be H, and then you'll take whatever the K value is and you'll add to whatever P is. And again, I'm giving you the equations. We'll sit down, we'll work it all out, and you can kind of see the difference. If it's horizontal, now the P value is added to the X coordinate. Okay, so there's where the focus is. Now the directrix, the thing about the directrix, it is exactly also P units away from the vertex. Okay, and so what we'll do is we're going to get a line that is perpendicular to that axis. Remember your axis from algebra class. And so we're going to get that directrix is perpendicular to that. So if it is a vertical line, you have a horizontal directrix. So we know that when you write an equation, that's the big thing, is that a directrix always need to be an equation. We're going to say that it's y equals, well, since we went the opposite way, it's k minus p. If you have a horizontal parabola, you're going a vertical directrix line. So it's going to be x equals that h minus p. Okay, so there's just some equations for you to use, finding your information you have there. The nice thing, or the important thing about the focus and the directrix in correspondence with the parabola is that no matter where you draw the line from the focus out to the parabola, and if you were to go straight down, if we had actually had a really good accurate diagram here, these two lines are always going to be congruent to each other, no matter where you are on the parabola. Okay, so that's an important significance in terms of drawing your graphs, all right, that we'll look at later on. Okay, so now back to our chart here. If you look at the axis, that's just like you've been doing since you're in algebra class. That's always just x equals h, right? Whatever the x coordinate is of the vertex. And this is always going to be y equals k. Right, so a little bit different there, but we're looking at the y coordinate, and we'll get to all that stuff later on, okay? Last thing is the focal width. If you look at the equation, we had that 4p in there. So the focal width is actually just the absolute value of 4p because it's always a length, okay? So that's why you look at the absolute value of it. But as you look, what that actually is when you look at the diagram, and I'm going to move this blue line here for a second, okay? if I were to go parallel to my directrix through the focus, hence focal width, if I were to go through there, that green line is my focal width. Okay, so that's going straight across, parallel to the directrix, perpendicular to that line between the vertex and the focus, all right, and that goes straight through the middle there, and that helps us draw. We'll use that as we do some of our examples here in a little bit, okay? So, but there's all your information that you need. And some of that chart you can go back to and use as a reference. I'm going to show you how you can also, if you're a visual person like myself and you aren't big on memorizing, you can always kind of use diagrams to help you figure this out. We'll get to that in a few minutes, okay? All right, so now how this works. If it opens up or down, okay, this is what you've been doing since algebra class. Y equals a parentheses x minus h squared plus k. That's what you did back when you were doing all your algebra class. But we're not going to use this now. We're actually going to use the conics form in this part. And this, like I had listed up above, if it opens up or down, x minus h squared equals 4p y minus k. That's the equation that you need to understand and memorize, because that's how your answers need to be on your tests and quiz. So to avoid losing silly mistakes because you have it in the wrong form, put in conics form. Now the vertex form, which we probably never have used, is x equals a y minus k squared plus h. Again, we know you need to know that form because we're not going to use it. You're going to be looking at if it opens left and right, you're going to be, as I listed up above, y minus k squared equals 4p x minus h. Those are the ones that you need to memorize and be able to use over and over and over again. Okay, we're going to go through those. Now you say, well, how do you know if it opens up versus down? It's the exact same equation. It's all based on your p-value. It's going to open up if p is greater than 0. It's going to open down if p is less than 0, right? That just means if p is positive, it opens up. If p is negative, it's going to open down, okay? Now, the other one that you can see is, well, how do you know if it opens left? Well, that's if p is less than 0, it's going to open left. If p is greater than 0, it's going to open right as long as the y quantity is squared. Okay, we're going to focus on a lot on that. You can just have that in your notes as a reference, but we'll use, we'll practice that as you go through some of these examples. Okay, so let's get into it. I always love the examples, right? Here we go, practice problems. Our job is to state the vertex and the focus of the parabola having that equation. So the first thing you should identify when doing any of these is it x squared or y squared? Well, looking at that equation, hopefully you recognize, oh, it's y squared. So we know that this is going to be either, this is going to be a sideways parabola, either going left or going to the right. And we got to make that decision. Either case, we know that our vertex is going to be 5, 3, because here is your h value, there is your k value, just like we do with circles. The x coordinate goes with the x, the y coordinate k goes with the y, right? You got your 5 and your 3, okay? The next thing you're going to do for all these problems, and this is the next thing that comes in here, is you look at this 8, and it's there for a reason. If you remember from up above, as you can see that we have this equation up here, right? We know that 4p is equal to 8. So because 4p equals 8, we know that p is equal to 2. Well, the significance of that is because it's a positive number, we know that we're looking at a parabola that opens to the right, okay, because it was y quantity squared and it was a positive p-value, so it's opening to the right. So when I want to figure out my focus, right, so if I draw a little bit nicer one here, we have that this is your vertex. To get to the focus, it's always inside. So all I'm going to do is take 2 steps inside the parabola when I want to find the focus. So you can either go up to this equation, right, that we had at the beginning, and it says you want to find the focus, that we could go through and do h plus p comma k, and you can memorize that and use that, and that's perfectly fine. But like I said, if you're a visual learner like I am, what you may want to do is say, well, if I start at 5, 3, and I take 2 steps to the right, my focus is going to be at 7, 3. And that will give you the coordinates of that focus. Again, if you're great at memorizing equations and you'd rather use that, if you remember the equation for the focus when it's a horizontal parabola is h plus p comma k. So if you'd rather do this because you memorized it, 5 plus 2 comma 3. Oh, look, you get the exact same answer, which you should. It just depends on what your preference is. If you're a visual learner like myself and you want to just draw it out and start plotting points, that might be easier. If you want to use the equations because you're great at memorizing the equations, then use that, okay? You can use either way to get your information, either from the vertex or the focus. But everything starts with the vertex. You got to make sure you find that correctly, all right? Let's take a look at number 2. State the vertex and the directrix based on this. Well, looking at this, x quantity is squared, so I know I take that and do the opposite. I got -3 and +1, right? Comes right from there, comes right from there. Okay, just like doing the circle, right? The vertex or the center of the circle, exact same concept. All right, now since it's x squared, we know that it's going to open up or it's going to open down, and we have to make the decision. Which one is it? Well, hopefully, if you take a second look at it, if you guessed it and you said, I see that I have a negative, so I know that it opens down, you would be correct. Okay, and so what we can do is we can go through and say, all right, well, I know that 4p is equal to -20. That's just in the equation. It's always that number that's in front there. So p equals -5. So that's why I said, if you said opens downward because the p is a negative value, you were right. Now, if you take a look at your graph here, so if we were to look here and look at a quick graph, we're at -3, 1. We'll see right about there. There's our vertex, okay? We know that it opens downward because we have the negative p value. So if I were to graph one that opens downward, my focus would be down there, but that's not what it's asking me for. It's asking me for the directrix. So I would have to go the opposite direction, and there is my directrix, okay? So because it's a horizontal line, I know that my equation is going to be y equals, well, if you started at 1 and you went 5 steps upward, right, to get away from the parabola, so you'd go upward to get to that directrix. Well, instead if I start at 1 and go upward 5 steps, I'm going to be at y equals 6. Okay, and that is going to be your vertex, and that is going to be your directrix. Again, if you're a person that likes to go through and use equations, that's perfectly fine. If you go up and look, it says that the directrix for that is going to be y equals k minus p. So you say, okay, well, if I do that, I have y equals, my k value is a 1 minus -5. Oh, look, that's what makes it for the difference. I still get y equals 6. Okay, so you can use either the equations to get your answer, or you can go through and just plot it and use your steps. Either way, you should get the exact or the correct answer. So just pick whichever your preferred value or preferred method is and go with it. Okay, all right, let's take a look at day 2. Now we got some graphs on here that we're going to look at. So we got to state the vertex, directrix, and direction of the parabola, and then we got to graph it. If you look at that equation right now, this is what you would have seen in algebra class, right? A y equals equation, in vertex form, quantity squared, all that. But we got to make it into the formula of the conics form so we can get our information. So what I'm going to do is I'm going to add 1 to the other side. So I'm going to say y plus 1 equals 112 times the quantity of x minus 2 squared. Now, if you look at this, I see that the x minus 2 is the quantity that's squared. I'm going to move that, right? I'm not doing any algebra. I'm just moving it to the other side to get that on the left-hand side and the side that's squared on the right-hand side. So I do is move it to the other side. Now, to get it by itself, right, the proper form for conics, I need to multiply both sides by 12. So I have x minus 2 squared equals 12, and of course you left it as, and you put parentheses to say the quantity 12 times that group of y plus 1. So now once I have that information, now, or having the correct form, now I can find everything I need. So I say, all right, well, my vertex, well, that's just really easy. Opposite, right? It's a nice thing. I noticed that, right, I like to do this right away also. I noticed that the direction, well, it opens upwards, right? You say, well, how do you know that so fast, Mr. A? Well, here you can look. I have a positive p value, right? Because 4p equals 12. So I know that P is 3. It's a positive. The X is what was squared, so that's going to tell me that's going to move upward. Okay, so if I start my graph, if I'm at 2, -1, if I go up 3 spots, right, this is my vertex right here. If I go up 3 spots, I go 1, 2, 3. There is my focus, right, because the parabola is opening upward. To find my direction, I go 3 steps the other way, 1, 2, 3. I know that right here, that is my directrix. So if you look at a good equation, you can say, oh, my directrix has the equation. It's a horizontal line. So y equals 1, 2, 3, down to 4. And there is my equation. It's moving up, and there's my vertex. Now, this is how you need to do your accurate drawings. Don't just wing it. Don't just be like, we're just going to go like that. No, no, no. You're not going to get full credit. Instead, what you want to use is the focal width. All right, remember we talked about that on the front side. We drew that in green on the front page. So the focal width, well, that's just the absolute value of 4p, or real simply, that's just this number, the positive value of it. So my focal width is 12. So all I need to do is if I cut it in half, I know that from the focus, and we'll actually make this green also to match up, okay? From the focus, if I were to go 6 steps, 1, 2, 3, 4, 5, because it's cut in half, 6x to the right, 6 steps, 1, 2, 3, 4, 5, 6. To the left, if I were to draw that in, that whole, from green dot to green dot, that whole thing is my focal width. Okay, that's the ends of the parabola going through the focus. So now, if I just make a nice parabola, because I could have made that back in purple, but that's okay, right? That, hopefully you drew a little nicer than I did, that whole thing would be an accurate parabola. See how we didn't just wing it like we talked about up there. We actually drew a nicer parabola that goes to those coordinates. That's your teacher's going to be looking for when they're grading your papers because they want you to be more precise than just drawing a random parabola graph, okay? So you be more precise, all right? Awesome. There's number 3. Let's take a look at number 4. State the vertex, directrix, and direction that we got going on here. So the nice thing is I got nothing being added or subtracted. So my vertex is 0, 0. I can see that it's already in my conics form. So I can just set it up like this. Because it's x squared, you say, well, it's either going to be opening up or down. The -8 tells me this is going to be opening down. So I can start at 0, 0. I have my p-value. Well, 4p is equal to -8. I know that p is -2. So if I go 2, so this is my vertex up here. If I go 2 steps down, this would be my focus right there. If I go 2 steps the other way, because it's all based on what the P is, if I go 2 steps the other way, I can see my directrix is going right there. So I can say that my directrix has an equation of y equals 2, right? Just kind of setting things up there, okay? Now, the last thing is, again, I want to draw an accurate diagram. So I know that my focal width, now remember, it's always the absolute value of that particular number. So that's why the focal width is +8. You're talking about a distance. You don't say you take -8 steps. You would say you took 8 steps in a certain direction, right? So we're going to say that's a positive value. So I know that if I go 8 steps from the focus, meaning 4 and 4, I got to cut it evenly. So 1, 2, 3, 4. 1, 2, 3, 4. From there to there, that is my focal width. Okay, so to draw a nice parabola, connect to there, keep getting wider, make sure it doesn't bend in, right? Earlier in the year, we talked about passing the vertical line test. If you bend it in, it's not going to pass the vertical line test. So make sure it goes wider and you get your arrows in there, and so you show a nice parabola, okay? So there's our vertex, our directrix, and our direction for that parabola, and there's a nice looking graph. Whew, hopefully yours looks just as good as that one does. All right, number 5. So right away you should notice and say, okay, that's not in standard form or not in conics form. So what I need to do is I need to subtract the 28x to move it over to the right-hand side. So I know that because it's, again, my vertex is just 0, 0. That's pretty easy because nothing's added or subtracted. So I have that part of it. Here's a little bit trickier one. If 4p is -28, I know that p is -7. Hopefully right away you notice because it was y squared, it's either going to go left or right. And because we have a negative number, that means that this is going to be opening to the left. Okay, so hopefully you see that. So when I start here from my vertex, I mean, I'm putting the V's on there to help you. You can do it up to you. It's up to you. If I go 7 steps, 1, 2, 3, 4, 5, 6, 7. Ooh, ran to the end here. That's where my focus is. Because it's opening left, the focus is always inside the parabola. Remember that. So if I go 7 steps to the right, here is my directrix. So the equation of that directrix, well, because it's a vertical line, it's x equals, right? When it's a vertical line, you x equals. Well, what is the number? It's going to be x equals 7. Again, if you want to use the equations that I gave you at the beginning of the lesson, you can go through and plug in the numbers, and you'll see that you get x equals 7 as well. Now, the tricky thing is that my focal width, or my 4p, oops, my focal width is going to be the absolute value of negative 28. So that means it's going to be a positive 28. So that means that graph, you probably should have cut that graph in half. But as you're going through here, some big numbers we picked. So you got to go 14 way up there. I know I'm just going to eyeball it here. Really, I know it's not 100% perfect, but that's the idea. Obviously, test or quiz, you'll get nicer numbers to deal with. But there is, I guess I should have switched to purple, but that's okay. And there is your parabola. Okay, so that's going to be really wide because that p value is so large. That focal width is so large on there. Okay, all right. Let's get a little more complicated one. Let's get into number 6. So right away you look at that, you say, all right, I got to put that into conics form. Here's the tricky thing, because we need to do some completing the square. That's where we reviewed that the last couple of days. So what I'm going to do is I'm going to, because this is the one that has the quantity squared, I'm going to factor out the 2. So not the x though. The x stays in there. That's a mistake I see students make. They take out a 2x. What are you doing? That's not completing the square. That's being silly. All right, so I'm going to take out the 2. I got x squared minus 6x. I'm going to add the y and move that to the other side. I'm going to subtract the 18, move that aside, and do proper algebra. And I'm moving it over there on purpose because that's what my conics form looks like. So it needs to start getting in that order. Now, if you remember from completing the square a couple days ago, we would take half of the b value. So half of negative 6 squared gives me a positive 9. Here's the tricky thing. Because there is that 2 in front of that group, we really didn't add 9. If you think about it, if I were to distribute, don't distribute. Just think about it. If you look at it, if I really, instead of adding 9, I added 18. So in order to balance is I have to add 18 to the other side. That's a tricky one for students. If you can do that, then you are awesome. And then eventually all of you will be able to do that. Just got to practice, okay? So we have plus 9, actually really adding 18. So I'm going to add 18 to the other side. So now it's all set for me, ready to go through and factor, right? This was the process we spent a couple days on. The nice thing is the 18s cancel, so I just get equals to y. I'm not in proper form yet. I need to divide by 2. So x minus 3 squared equals 1/2 of y. Now I'm in the proper form. So now I can figure out, all right, my vertex, that's going to be 3, 0. It's x squared, so I know it goes up or down because it's positive 1/2. That means it's going to be opening upward. Okay, here's a little bit trickier part. I know that 4p is equal to 1/2. Be careful with your fractions. So I know that p is 1/8. So if I start at 3, 0, that's my vertex. I have to go up 1/8 to get the focus. So it's almost like on top of each other, right? And you can't even see it. It's so much on top of each other. My directrix is 1/8 the other way. Whoops. Don't want to go to the next page yet. 1/8 the other way. So that means that my directrix is y equals negative 1/8. That is my equation, my directrix. Pretty crazy, but that's what it is. Okay. So now if I do my focal width, well, focal width is 1/2. I'm going to go 1/4 on each side. So I'm going to go and right there. Oops. Right there. Right there. We'll get rid of this one right here. It's going to get a little messy in here. All right. And so my, as crazy, as tight as that is, the last one was so much larger. As tight as this one is, it's going to go like that. And that's going to be much tighter because the p-value is much smaller. Okay, so you got to kind of look at that and see as you practice each of these individual problems. Okay, so there's some basic ones of just finding the information from an equation, stating the vertex, find the directors. Again, if you're a person that likes to use the equations, go back to the front page and use the equations. If you're a person that likes, like me, likes to look at things and plot stuff, get the information, after I start finding the p-value and plotting it, then do that. It's all based on what your preference is, okay? All right, let's take a look at the third page right here. Now we're going to talk about something called the focal ratio. It's just the ratio of the focal length to the diameter at the focus. So basically, when you look at the focal ratio, if you were just to have, there's a vertex, and let's say I have a parabola right here. Oops, if you hit it. And so this, we know that from here to there, that would be the d value, the distance between there, the diameter, right? As we're looking at that, that's the diameter that's there. And then obviously you have a focus that's right here, and we know that from here to here is your p-value. And we know the focal ratio is a simple equation. It just takes the p-value divided by the diameter. That's all that it is. Okay, but again, what it does, it has significance when you're looking at different things like sound for a vision for a satellite dish, things like that. That's where the significance comes in for your engineers down the road. You'll be looking at things like this to measure out when am I getting the best situation. Look, where should that focus be? Again, I'll leave that for all you engineers down the road. Please come back and tell me multiple years from now when you get there. But we're going to have some questions on this. Let's answer how it works. So number 8. Says just find the distance given the focal ratio is 0.3 and y squared equals 120x. So really simply, if I take that equation, I know that I'm just going to abbreviate here, focal ratio is equal to the p-value over the d-value. So my focal ratio, it tells us, is 0.3. The d-value I do not know, right? That's what's asking me, find the distance. So I got to know what the p-value is. Well, use the previous stuff we've been working on, right? And off to the side, if I know that 4p is equal to 120, I know that p equals 30. So if I plug that into my equation, right? Just using this equation right there, that's all I'm doing. So if I solve this carefully, be careful with your algebra, let you think it, and you guessed it, 100. So hopefully that's what you got as your answer as you went through and solved that. Okay. All right. So that's just how you can use the focal ratio to help you in those types of problems. You'll see a couple of those in your homework. We'll look at another one just a minute. So if we look at number 9, given the parabola vertex. So now we're switching gears. We're changing spots. I'm giving you information. You give me the equation. Okay. So what I would do first thing is plot what you know. I have a saying in my room, some of you that are in my classroom, when in doubt, draw it out. That's what I always say. When in doubt, if you're not sure, let's draw it out. So if I go out 1, 2, 3, 4, 5, 1, 2, 3, if I were to put my vertex right there and my focus is 5, 4, so there is my focus. Well, I know, or you should see that this is opening upwards, right? And since opening upwards, we know that our basic equation that you've memorized, x minus h squared equals 4p y minus k. I'm going to do is plug my information in. X minus 5 squared equals 4p y minus 3. Right? And just put my information in there. Okay. Now the only thing I need to find out is what's the p-value, because I can't leave it like this. And since it opens up and I can see the distance from the vertex to the focus is 1, I know my p is 1. So all I got to do is plug that into my equation, and I simply just get x minus 5 squared equals 4 y minus 3. And there is the equation where the vertex would be at 5, 3, and the focus would be at 5, 4. Okay? All right. Last one we got here. This one is it's from your book. I'm going to try my best to draw this out. If you need to go back and look at the diagram, go back and look at the diagram from page 859, number 25A. Basically, again, we just need to find the equation based on the information given. Now, I'll try my best to draw this. It's not going to be pretty. I apologize. But this is what's going on here, is we have a bridge that's going like this. It tells us that from end to end, it is 40 feet. And it tells us from the vertex down to the bottom of this part here is 15 feet. Okay. And they tell us the suggestion is to put the vertex on the x-axis and that x equals 0 is where the vertex will be. Well, simply put, all this information is telling us is that our vertex is at 0, 0. Okay? So what I can do is I got to find the equation of this particular parabola, right? Put it in green. We'll highlight that in green. So that's what I need to figure out. What's the equation of that? All right? So what I'm going to do is, based on the information given to me, I can find a point that's on that parabola, right? Because if this whole thing was 40 and it gets cut in half because of the symmetry, right? Cut that in half. I know this coordinate is going to be 20 spaces to the right, because remember, the vertex is at 0, 0. Okay, so it's 20 spaces to the right, and I'm going down 15 spots. So what I know then is I can take that coordinate, this is my x, and this is my y, and I can just plug it into this equation. So I know that I have 20 squared equals negative 4p times negative 15. And the reason I'm plugging it is I got to figure out what the p-value is, right? So I'm going to plug these numbers in here in order just to solve. So 400 equals 60p. So if I were to go through and solve, do some careful dividing, I get p is going to be equal to 20/3. So now that I know that p equals 20/3, right? Careful your negatives and everything. I'm just going to plug that back in. And this bridge, if I put the center of that vertex at the 0, 0, and I plug that in, I'm just going to get x squared equals negative 4 times 20/3 y. And if I clean that up, x squared equals negative 80 over 3 y. And there's your final answer for that parabola underneath the bridge, okay? All right, good luck. Again, practice those formulas. Make sure you see the difference between vertex form and convex form. Make sure you're able to go through and find the information that you need, okay? If you got questions, ask your teacher.